Hello students. Today we're going to go over graphs of nonlinear functions, Saxon Algebra 1, Lesson 95. Don't forget that you can pause the video or watch it faster or slower, whatever suits your learning style. We're going to learn to recognize four important functions. These functions are the quadratic function, the cubic function, the square root function, and the absolute value function. None of these functions are straight lines. They are non-linear functions. We will also learn to recognize the negative counterparts of these functions. Number one, the quadratic function y equals x squared. The shape of the quadratic function is a parabola. Parabolas are not only interesting mathematically, they have very practical uses. For example, long-range telescopes are parabolas. The parabola y equals x squared sits on the origin 0, 0. That point is called its vertex. The negative quadratic function y equals minus x squared. When y equals minus x squared, the parabola gets flipped around the x-axis. Now it hangs from the point 0, 0. 0, 0 is still the vertex. Number two, the cubic function y equals x cubed. The cubic function has an interesting shape. It starts way down in the negative numbers, then comes up and does a little flex around the origin, and then goes way up into the positive numbers. When x is negative, y is negative. When x is positive, y is positive. The negative cubic function, y equals minus x cubed. When y equals minus x cubed, the function gets flipped around the x-axis. Now, when x is negative, y is positive. When x is positive, y is negative. The negative cubic function starts way up in the positive y values, does the same little flex around the origin, and goes way down into the negative y values. Number three, the square root function, y equals the square root of x. The square root function has a shape that reminds me of a helicopter taking off. It starts at the origin, 0, 0, and curves up to the right, like I imagine a helicopter doing. Why does it start at 0, 0? Remember that the x in the square root of x must be greater than or equal to 0. The x cannot be negative. Negative numbers are not in the domain of the square root function. The negative square root function, y equals minus the square root of x. When y equals minus the square root of x, the function has the same shape. It still starts at the origin, but it curves downward. When y equals negative any function, that function gets flipped over the x-axis. This graph has both y equals the square root of x in red and y equals minus the square root of x in blue on the same set of axes. It makes a sideways parabola. Perhaps that will help you to remember the shape of these two functions. Number four, the absolute value function, y equals the absolute value of x. The absolute value function has a V shape. This is because the absolute value function always returns a positive value. The absolute value of x is positive. The absolute value of minus x is also positive. Some points are plotted on this graph. When x equals minus 1, what does y equal? Y equals the absolute value of minus 1, which equals 1. The ordered pair is -1 for x and 1 for y. The negative absolute value function, y equals minus the absolute value of x. The negative absolute value function has an upside-down v shape. This is another case of a function being flipped across the x-axis. The negative sign makes all the absolute values negative. Some points are plotted on this graph. When x equals -2, what does y equal? The function tells us that y equals the negative absolute value of -2, which is -2. The ordered pair -2 is on the graph. The point of this lesson is to teach you to recognize these functions and be able to match them to their equations. So let's take a little test. This is A, a quadratic function, B, a cubic function, C, a square root function, or D, an absolute value function. It is a quadratic function. In fact, it's the negative quadratic function, y equals minus x squared. This roof is A, a quadratic function, B, a cubic function, C, a square root function, or D, an absolute value function. It's an absolute value function. It's the negative absolute value function, y equals minus the absolute value of x. This graph is A, a quadratic function, B, a cubic function, C, a square root function, D, an absolute value function. Don't be fooled because it's exaggerated. It's a cubic function. Y equals x cubed, but this cubic function has more terms than just that one. Now let's match the function name to the basic equation. The quadratic function. Can you find it? There it is. The cubic function is all the way at the bottom. The square root function is all the way at the top. And if you know which one is left, you know that that's going to be the absolute value function. How to recognize the equation of a graph. For the quadratic function, you are looking for y equals x squared or y equals minus x squared. There might be a number before x squared. But no matter what else is in the equation, if you have y equals x squared or y equals minus x squared, even with a number there, that's a quadratic equation. The cubic function is very similar. You're looking for y equals x cubed or y equals minus x cubed. There can be a number in front of the x cubed. Like it could be 7x cubed plus 6x squared plus 5x minus 4 equals 0. You see that 7x cubed, it's a cubic function. The square root function, you're looking for y equals the square root of x or y equals the negative square root of x. And again, it could have a number in front of it. Y equals 3 square roots of x plus 7. The absolute value function. You're looking for y equals the absolute value of x or, oops, I'm obscuring that, y equals the negative absolute value of x. The text shows 4 graphs of each function. One of the graphs is the basic function. Another of the graphs is the negative function, the one that is flipped around over the x-axis. You should be able to readily recognize those now. The other 2 graphs of each function are there to show you that the functions can be moved around the coordinate plane. One of these will be moved to the left or the right. The other one will be moved up or down. We will study these equations in Algebra 2. I hope this video was helpful. Please read through the examples starting on page 398 and make sure that you understand the answers, and then don't forget to try the practice problems. See you later.